Welcome back. Today we are diving into one of the best ways to improve the performance of your REST APIs, which is caching. Caching can help reduce server load, speed up response times, and provide a smoother user experience. In this video, I will explain how caching works, common caching strategies, and how to implement caching in your APIs. So let's get started. First, let's answer the question about what is caching. So what exactly is caching? Caching is a process of storing copies of responses so that future requests for the same data can be served more quickly. Like when an API response is cached, the server doesn't have to recompute or refetch the data for every single request. It can simply retrieve it from the cache. This can significantly reduce the load on your server and improve the response time. So if we want to take a real world example about how this work, let's say we have a client. Let's make it this bold or quite bold. Let's say we have a client, and this client sends requests to the server, and the server sends read and write operations to the database. So, for example, the client sent a read request to get, let's say that to get a user with the ID 123, okay? And the server will try to send the requests, the read request to get the user. And the database will send back the user with this ID. Let's say that we have many clients requesting the same user, the same request, the same everything. So this where the cache come into play. The cache is in memory storage that is faster than the database. We store in it the frequently accessed data. So first we improve the performance because since it's quite faster than the normal database, the client will be served quite quickly or faster than a normal process. Also, it will reduce the load on the database because all the frequently all the same requests will be served from the cache. So this is how the cache works. So let's talk about why caching is so important. Why does caching give us? So first, it greatly improves the performance of your API by reducing response times, since the server doesn't have to regenerate the data for every request. It also reduces the load on your server, which means fewer computations, fewer database queries, and ultimately lower infrastructure costs. Plus, the user will benefit from a smoother, faster experience. Okay. Now we need to talk about the types of the REST API caching. Let me just scroll. So there are multiple types. There is server side, there is client side, there is proxy caching, there is a lot of things. So let's start with start with what? With the client side. Okay, let's say client side, CS. So with the client side caching, the data is cached by the client, often in the browser, so that the client doesn't need to make repeated requests to the server. This is great for static assets like images or API responses. The benefit is that it reduces network latency, but the server has limited control over the caching, over the cache, or like over how the cache is managed. Okay. There is a server side, which is this example is perfect one for server side. This one is perfect one for server side. So server-side caching involves caching data on the server, which can then be served to multiple clients. This is useful for API responses or complex database queries that are requested frequently. With server-side caching, you have more control over how the cache is managed and when it gets invalidated. Okay. There is also proxy caching or reverse proxy, which is the last thing that we talk about. Let's say BC, proxy caching. So proxy caching uses a reverse proxy like Nginx or Varnish to cache responses on behalf of this API server. This helps offload the caching burden from the main server, as the proxy can serve cached responses without having to reach the original server. Sorry. Number five, we need to talk about how caching works in HTTP, because I guess you will get this question in your system, in your API design interviews. So caching in HTTP is control using headers like what? Let's talk about the headers because it's important, in my opinion, to talk about them. The headers like a cache control, like cache control, e tag, and expires e tag. Like for example, the cache control will look like a cache control. It will have like max age. Let's say the max age. It will be something like that, which tells the client to cache the response for 1 hour. You can also use etag to check whether the cached response is still fresh, and if not, the server will return 304, which is not modified response. And yeah, this is how an expires. It expires in when. Let's also talk. We can make a demo example for that. I will make like a quick demo for us to see. Let me put a coding block here and just put the code here. So let's see how we can implement caching in Node.js API. So I'm adding here cache control, as you can see. I'm adding here cache control header to set the cache duration to 1 hour. After the first request, the response will be cached, and subsequent requests within the hour will be served from the cache. Also, there is, I would say, one of the things that is quite important, which is to talk about two things: the cache invalidation and the best practices. Let's talk about the caching invalidation strategy, but let's just make the text way more smaller. So one of the trickiest parts of caching is the cache invalidation, ensuring that stale data doesn't stay in the cache for too long. And a common approach is to use a time-based invalidation like cache control, which is max age, as we discussed earlier, to expire data after a certain period. Another option is to use etag validation, where the server checks whether the cached response is still fresh before serving it. You can also manually clear the cache when you know the data has changed, such as after a post or put request. I would say also we have the second thing that we need to talk about, which is the best practices. Okay. So, when implementing caching, follow these best practices, in my opinion. First, cache non-sensitive data only. Avoid caching personal or private information. Second, Set appropriate cache duration based on how often the data changes. Third, have a clear strategy for cache invalidation to prevent serving stale data. Finally, monitor your cache performance regularly to ensure you're hitting the right balance between fresh data and performance. So, in conclusion, in today's video, we explored caching in REST APIs, how it works, and how to implement caching strategies to improve API performance. So, see you in future problems.